Okay, so once you load up the web page, you'll be greeted with this page right here. This is the home page. If we scroll down, you have these free cards which you can click these hyperlinks, buttons, which will take you directly to the page. You also get to these pages by selecting the tabs at the top. So biology and ecology here. You also have the contact details if you want to get in touch of the references, but we'll go on to that later. So starting with ecology, this is basically an overview of what methanotrophs are and their ecology in particular. So just giving some basic background, they're these prokaryotes which are able to metabolize methane as their source of carbon, and a lot of them are. This will be covered in the taxonomy uh, page a bit, but they are a lot of them are bacteria, but there are some which are archaea. Of course, they use different um, mechanisms or different ways to um, metabolize methane. Of course, different um, intermediates, different pathways, even sometimes different ways of respiring. So they're generally found in wetlands, soils, marshes, rice paddies, just where you expect. Um, and going through again, there is some interest which has been sparked because, of course, um, methane is a harmful greenhouse gas, and when you're able to use methane as a form of fuel, as such, as a source of energy for an organism, becomes quite enticing because, of course, um, nowadays the a big concern is climate change and also global warming, which, if this can help, it definitely should be looked into. And of course, this is a chart of where of what like um, the average methane emissions are. Sorry, and of course you can see most of them are going to be in um, like as you see in the aquatic sources, most of them which are wetlands, which are going to be the primary one of the primary habitats for um, Methanotrophs. And for biology, of course, you can see um, how they oxidize methane, how they process methane, and of course this chemical equation helps demonstrate it much nicely. But it is just a general oxidation to an alcohol, so it would be oxidized to methane, from methane to methanol, and of course that's helped by the presence of an enzyme called methane monoxidase, which of course helps to, um, of course, catalyze this reaction, and it's done by allowing the CC bond to act as an electron donor and a source of carbon, and of course using the oxygen as a um, electron acceptor. And this is um, a micrograph of from an electron microscope of Methalococcus capsulatus. and there's some information here about um, how it helps with oxidation, referring to monooxygenase. And when we go to taxonomy, yeah. So when you scroll down, you'll have uh, the different taxonomic labels here. So you have domain, of course, it's showing that it's bacteria with some archaea being an exception to the rule, as in most of them are bacteria, but there are some which are archaea. And for kingdoms, they're mainly eubacteria, and for phylum, they're protobacteria and uh, uh, very common microbia. And this one here, very common microbia, it's a newer one because it's been discovered in 2007, which is fairly recent. And for class, protobacteria is put into two classes: gamma protobacteria and alpha protobacteria, given names type 1 and type 2, even though sometimes you'll see type 2 as type X. And of course, for the newly discovered class, you have microbiae. And going back to the protobacteria, two classes, they're really separated because they have different phylogeny, carbon assimilation pathways, and internal structure of the cell. So type 1, they do it. They incorporate carbon via the ribulose monophosphate cycle. They're phylogenetically gamma protobacteria, and also their membranes are for type 1. They form these disc-shaped vesicles which are distributed across the entire cell, in comparison to type 2, where their internal membranes are paired, but they're along the outer of the shell only. And in type 2 as well, they use the serine pathway, and they're phylogenetically alpha protobacteria. And then you have it for orders. You have gamma protobacteria being Mylococcus. You have alpha protobacteria being Rhozobius, and you have the newer Vericomicrobiae being having the order of Methanotrophs, phallus. So, and type 1 you have Methylococci being the family, one of the families. Okay, and for type 2 you have these two different families, which this one is newer and will be talked about a lot less because it's generally a lot less known. And then for the newer order you have, of course, the corresponding family. And for genuses we can go through these, but they would take too long, so I'll just go through slowly. And for species, this is even longer, so I wouldn't consider I wouldn't think it'd be a good idea to read them all off. But going back to one of them being Methanotrophs, there's two different groups which have been considered to be classified differently. Being one species is more mesophilic, and the other one being more thermophilic. So one of the things which distinguishes these two, one of the ways how you can tell the difference is by their G plus C value, which is going to be much higher at 59 to 66% per mole. For the thermophilic Methanotrophs species, and then for the other species which are going to be more mesophilic, it's a G plus C value of 48 to 55. And if we go back to the top, we have the search bar, so you can type in, let's say I wanted to find genus, like what the genus is. I could type this in. Of course I can't do this because this is the preview mode right now, but you can also look at the references, and each one of these buttons are hyperlinked. So when this is for ecology. When I click on each one of these, which I can, it will go to the online source, which has been referenced. So starting with the ecology one, this one here, has been found here. This one here has been found here. And these two for these three for taxonomy are here. Then these three for biology are here. Then we go back to the top. And then going back to each individual one, the hyperlinks clearly work. You have the contact information again if you want to get in touch. We go back home. We can go back down and we can see the video channel where the videos may be available to look at. And that was our presentation.